Okay. So first of all, let's talk about a couple notation things. Okay.
Nouns and verbs.
Okay. dy dx is a noun meaning, hey, take the derivative with, or it means the derivative with respect to x. d dx means, hey, take the derivative with respect to x. So,
should we write this down?
But that's not there. That was school. That was school.
It's up to you whether you write it down or not. Okay? But I want you to understand the difference. So you're going to see like dy dx equals 2x. That's something that you would see once you evaluate a derivative.
That's when you're given a point, right? Usually, like if you're given like a point on the graph, like a plug in for that.
Well, they might ask you to evaluate it somewhere. Okay. Now this is saying please take the derivative of x squared.
Okay.
Okay.
So that's just the bottom one is what we've been doing.
They both what we've been doing. They're just two different notations. This means the derivative equals 2x. This one means take the derivative with respect to x of x squared, and it would be, I will tell you, 2x.
So that's like we would plug that into there.
Yes, use x squared. Yeah.
Oh,
Okay.
so the first one's saying like 2x is the derivative, and the second one's saying find the derivative?
Like
Yes. Very good.
Oh.
Okay. And then down here, this is the one that we talked about earlier. The derivative of a constant is 0 because the slope of a constant function is 0. They'll run in the rain.
They'll still run as long as it's not really hot.
Not if it's all muddy.
They'll still run.
They'll still run. As long as it's not lightning, they run.
We would play tennis, but it's a dangerous activity.
Flipping edge.
Yeah.
Right.
yeah.
Okay. So today we're going to talk about graphical relationships. Okay? The graph of the derivative represents all of the slopes of our original function. Okay? So what is a derivative? The slope of the tangent line. Okay? So what we can do is we can find all of the slopes from our curve, and if we plot those values, we get a derivative graph.
We're just doing a graph.
Okay, so like, okay. In number, what's the problem that we did? We did the x squared.
X cubed, X squared.
We did x cubed plus x squared, right? So in whatever problem, I'll write it down here. In whatever problem that we did, our function was x cubed plus x squared. And we found that the derivative was 3x squared plus 2x. Okay, so here is your function, here is your derivative. The graph of this derivative is coming from all of these slopes, right?
Your derivative will be a line or anything with
There's going to be a relationship that we're going to talk about later, but it's not always going to be a line.
That would make a parabola, but you never actually about it.
Okay, so we've been talking, like, our problem of the day was an individual tangent line, where we found the derivative and evaluated at one point, right? So our derivative is going to be a function, okay, not necessarily a line, okay? So here we go. Here we have x squared, and the derivative of x squared, you found this morning, was 2x. Okay? So let's talk about some relationships. Okay, so here, our tangent line has a slope of negative 18. Which means, okay, so at x is negative 9, our slope is negative 18. So the point on our derivative graph is negative 9, negative 18.
With zero.
Okay, so at x equals negative 9, our slope is negative 18. So negative 9, negative 18 is a point on the derivative graph. Let's talk about another one. Here, at x equals negative 4, our slope is negative 8. So here's the point, negative 4, negative 8.
But they're two different.
Is he gonna always?
What?
Like, go back this one.
Oh,
Like,
it's
the
on.
first
Oh, I
tangent
see.
line is different than the second.
Well, the second line's the derivative, not the tangent.
Right, because the derivative is the slope of the tangent line. So I'm taking different tangent lines and comparing them to our graph.
The derivative.
Okay, so now, what's the derivative here?
Zero.
0. So at 0, our slope is 0, which is why we have the point 0, 0 here. Okay,
I'm sorry.
okay. Whatever our derivative is at a point, okay, so whatever the slope of the tangent line is, that is the y value for our derivative graph, okay? So if our slope is 0 for our tangent line, then on our derivative, our y value is 0, okay? So what's true about these tangent lines? What's true about the slope of the tangent lines on the left side of this graph? They're negative, okay? How could you describe the left side of this graph? Decreasing?
Yeah.
Maybe? Okay. So since this is decreasing, all of these tangent lines have negative slope, which is why we have negative values here. What's happening on the right side of our graph? We are increasing, so all of these tangent lines are going to have positive slope, which means we are positive on our derivative. Okay?
Mhm.
Whenever we are increasing, our tangent line is going to have positive slope, which means we're going to have a positive derivative. Anytime our function is decreasing, those tangent lines have negative slope, which means our derivative is negative. Anytime our function is constant or switching directions, we have 0 slope, so we have 0 for our derivative. Oh yeah, I have just the worst headache ever.
Same.
Yeah, this weather is just rough.
There's enough. Upstairs.
Increasing means positive slopes, positive derivative. Decreasing means negative slopes, negative derivative.
So as you like go from the left side to the right side.
Always from left to right. We read words left to right, we read graphs left to right. Okay? So we're going to look at some relationships of functions and their derivatives. Okay? Are you ready? Okay. Here is our function. Okay, does this look familiar? Okay. We are decreasing from negative infinity until 0. And so our derivative is negative. There. Here we switch directions. So our tangent line has slope of 0. So that's where we should be 0 on our derivative. From 0 to infinity, we're increasing, so our derivative should be positive. Okay, let's look at a new graph, because that's one we've seen.
Couldn't you just flip the derivative and do it on the other side too? You know what I'm saying? Like,
No, I don't know what you're
so
saying.
like go back one. Like see how the line is like slanted from left to right, that's prime or whatever. Couldn't you use some reflection, like reflect it, and then it would be tangent on the left side of the first function. Like so if you see the f prime, see how it goes from left to right like that? What if you like flipped it
Okay.
over the y-axis?
Okay.
And wouldn't it, you know?
Then that would mean this here.
No, I'm saying like,
No, yeah.
so like, if the line was like this, so instead of like that, it was like this.
Okay.
Can it like do that too?
No, because remember, these, like, right here, we have negative slope. So we have to be negative on our derivative.
Oh, so there's one like, for sure derivative.
Yes, there's only one derivative.
Alright.
Yeah. Okay, good question though. Okay, so here, what do you notice about this graph? It's increasing, right? So our derivative better always be positive. Okay, now here at 0, it kind of like levels out and then starts to increase again. So our derivative is 0 there. So it better hit 0 on our derivative.
Wait, so for like the derivative graph then, why is it, or can you just explain like why it's always, because isn't it negative on the left side?
Well, like tangent, the slope of the tangent line.
All of these tangent lines have positive slope.
Alright,
Do you see all of these tangent lines I drew?
yeah,
They all have positive slope,
yeah,
which means our derivative is positive. So these are all positive values.
alright, alright.
Okay, so this is what I would notice about this graph. Here at about -4, we switch directions. Here at, I don't know, a little after 0, we switch directions, and a little after 2, we switch directions. So those are the zeros of the what? Of the derivative graph. Good job.
That's what's
Okay? Yes.
Are the derivative graphs always 1 degree less than the derivative?
Hold on to that until Monday. There is a relationship there, yes. Okay. So decreasing, which means we're negative on the derivative. Increasing, which means we need to be positive on the derivative. Decreasing, negative. Increasing, positive.
That actually makes sense now.
Show me that it makes sense.
I got you, mommy.
You and the people around you,
Match?
I would like you to match 4 derivatives to their 4 functions. So on the left, you have functions. On the right, you have derivatives.
Right, we have functions.
Left functions, right derivatives.
So, the sulfur is going.
It's close enough. No, Zero is obviously big.
Number one is C. Because like these, they're going up, the tangent things are going up, which means like, this is gonna be above zero. When it drops down below zero, it starts to be like negative, the tangents go negative, so then that is.
And then it'd be a.
Very good.
I think. No, three is the.
Nice throw, we got that. Oh.
See, that's the difference about doing that square go down
No. I'm not doing it. Leave this off. Let's see if you can, what kind of pencil is it? Increasing.
Says zebra. 0.7. Zebra.
There you go.
I know my pencil throw.
Was that on there? It's not funny. Oh my god.
Zach, stop taking this.
What's that doing?
Doing my good.
Okay, Jalen. Number one matches up with what?
Had a girl.
One is C.
Oh, boy.
Do you agree?
I'd agree.
I do.
Increasing, so positive, switches directions at 0, so it crosses the x-axis at 0. Decreasing, so negative here. And then increasing, so positive. Number 2, Aaron.
Number 2 is A.
Yes, sir.
Like it?
Yeah.
Like it. Number 3, Carter, you're really excited.
D.
D. And then pod 4. What's number 4? Process of elimination. Okay. Now, 1 and 4 look very similar, didn't they?
Yeah. Yeah.
I did that on purpose, so you would really have to think about your graph and what it needed to look like, right? Okay. All right.
That's fine. It's hard.
You can't drag the graphs.
What up?
I know, I was really looking forward to it too, Mr. Moon, so. So just won't do it, you know, unless I don't do it.
4? Okay. Well, first of all, we see that we have 0 slopes here and here. Because it switches direction. Okay, so we know that we need to look for 0 on our derivative there. Okay, so we know that, you know, B and C are our 2 possibilities, right? Okay, well, in number 4, we are decreasing to the left of 0, which means on our derivative we need to be negative.
And then,
Increasing, we're positive derivative. And then decreasing. Right, so this is decreasing, which means we need to be negative. Great. Okay, one more thing. Okay, I want to talk about this again. Okay, the alternative form of the derivative. Okay, So this is still taking the slope of this secant line and taking the limit as we bring those 2 points together, okay? So we're still finding the slope of the tangent line, okay, using this limit process. But this is just a quicker way to evaluate it at a point, all right? You need to be able to recognize both ways, okay? Like I said, on the AP test, you're gonna get a problem where you're gonna have to recognize that it's a derivative, whether it's in this form or the original, limit as h approaches 0, blah, 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 that form. Okay?
So would you just plug like, if you have a point like 2, 4, would you just plug in?
All right, so what would we do in an example?
I don't know. Let's find out. All right.
Oh, I was gonna do it anyway. So the limit as x approaches 2 of
4 plus 12.
Please.
Okay, can you?
I get what it's going on.
don't we need to say f of x
Yeah.
minus f of c all over x minus c, derivative of the slope,
Why
right?
is it minus 6?
2. So we're evaluating the derivative at 2.
It's x plus 6.
Well, I was trying to understand like what f of c is. Is it supposed to like be something else or?
So it's our function, so this is our function minus the function at 2,
Oh, so you just
Oh,
plug, you just
my
plug
bad.
what the x is.
yeah, over x minus 2. It's Friday. So we have x squared plus 6x minus what?
12.
I don't remember it being 12, but minus 16. So to evaluate this limit, and what does it factor to?
X plus 8.
X
Plus 8.
plus 8. Okay? So when we evaluate our limit, we get evaluated at 2? Okay. So this means the derivative evaluated at 2 is 10. Okay, so I thought I was going to give you a QR code because I thought you could do this on your phones, but it turns out you can only do it on a computer. So let me give you that address. Here is the homework. It is in this order for a reason. Could you pull that back up?
Oh, so.
Why can't you just do?
Never mind. Hold on. So, I have a URL shortener, so let me get that shortened URL.
They have those things?
Uh-huh. Isn't that cool?
Copy that flip.
So we do the graph match and then this?
Yeah. So when you do the graph match, okay, do it on your computer. You can snap a picture with your phone and send it to me. You can screenshot it and send it to me. You can print it and bring it to me on Monday. I don't care. I just want you to do some graph matches, okay? I don't care how many of them you do, okay?
If we do one and send it to you, we're good.
How do we send it to you?
Email.
You have to email this to you?
Either email or print.
Should we do that or
Because
no? Or is it no?
You can't do it on your phone.
Can't do it on your phone. That's why. See, I had this nice plan of giving you QR codes so you wouldn't have to write anything down. And off, they were cool. Can't do it on your phone.
Okay, so the directions on it said like, I feel like when you knew it and everything, it'll give you like 4 more new graphs. So you just gotta have the first set of graphs, there it is.
Yeah, do the first set of graphs, and if you struggle with those, do some more.
But like, we just need to send you the first.
Yeah, once you complete your first derivative graph match, screenshot it, print it, take a picture.
Can you click on that and see where it goes to?
Yeah. Why?
So that we can just know.
Yeah, just
after.
Yeah.
The big derivative puzzle.
Okay, so what you do here,
Scroll down.
and then you match them up with.
Well, just, yeah. Oh, okay.
Oh, and it tells you if you're.
Have you ever been to Chico's? It's all popular.
You
Yeah, you pull bottles up.
Oh, hey, I wish. They don't have room in there. Honestly.
Wait, is it like that big coach bus or whatever?
It's that white van, that's the thing, I was like,
So-
No, the bus.
Well,
oh, no. It's
stop it! Stop touching my board! Stop! Stop!
Don't even touch it.
See, you can drag them in. See, okay, so this is why it wasn't working when you guys. So you grab it and you place it there, and then you evaluate. And I got 0.
Not a 10?
Boys.
I did not get any of it.
I-